Hi, good morning or afternoon or whenever you are tuning in today. Today's topic is exercise physiology. Essentially what we want to do now that we kind of understand the general concepts associated with each of the energy and systems within the body is apply a stressor to them. Again, as you already know, we've applied the stressor of environment, and now we're going to look at the stressor of exercise and how that affects our physiological functioning. Again, this is absolutely my favorite topic to discuss, so I'm very excited to share this information with you. So let's start out by understanding what is exercise physiology. Okay, so exercise physiology is essentially how the body works as it relates to exercise, and there are a couple different branches associated with this. Okay, so let's see if I can use my little pen here. This will be interesting. So there's acute exercise and there's chronic exercise. Okay, acute exercise looks at what is a change that's going to occur within that single exercise bout. Okay, so acute exercise, if I go outside right now and I decide I want to start running, what are some things that we are going to see physiologically that happen, right? So I'm going to increase my heart rate, I'm going to increase breathing rate, breathing frequency, I'm going to change my metabolism is going to increase, I'm going to start sweating, right? So all of those factors are acute. Those are going to change within that one individual exercise session. Chronic exercise has to do with if I exercise regularly over time, how does my body change? How is my body different as an athlete or someone who's a regular exerciser in comparison to somebody who doesn't do those types of activities? Okay. So again, if I chronically run, okay, let's say I run, 5 days a week, and I've been doing that for, years and years. Okay, what are some physiological changes that have occurred to allow me to adapt to that regular stimulus? Right? So I'm going to have a lower heart rate, for example. I might have a lower body fat percentage. I might have, let's see what else. I'm going to have an increase in stroke volume because my heart will be stronger. Okay, so when we look at chronic exercise, again, we're concerned with what are the adaptations my body can make over time. Okay, within either of these things, there's a couple different types of exercise, or really, let's say 3 different branches that we're concerned with. Okay. Number 1, I can do aerobic exercise. So how is my body different as it relates to aerobic exercise in relation to someone else? I can do resistance exercise, such as strength training. And I can do something called intermittent sport. Okay. Same when I look at how exercise affects me in an acute way. I can try to understand what's going on when I do intermittent sport. I can try to understand what's happening when I do one single resistance training exercise bout, and I can try and understand what's happening to my body when I do aerobic exercise, such as a moderate run or bike or swim or something along those lines. Okay. So a lot of different things going on here, right? So again, when we think about exercise physiology, think of all these different branches and all these different things that I could look at as I'm starting to study these things. Okay. So again, we kind of already defined these, but when we think about acute exercise, I am interested in understanding what's happening during one single exercise bout. Okay. Again, acute exercise can be related to resistance training, could be related to intermittent exercise. Intermittent exercise is like a team sport. So like basketball, for example. Okay. So I'm going to run down the court, I'm going to play defense, and then, somebody fouled. So now we have a short amount of a break, essentially. Okay, so with intermittent exercise, I'm starting and stopping depending on the demands of the game or the demands of that particular event. Okay. So again, with acute exercise, I'm trying to understand what are the changes that happen during one single exercise bout, regardless of what type of exercise it might be. With chronic exercise, again, I'm interested to see how my body adapts or changes as I chronically or regularly complete a particular type of exercise. And again, the chronic changes that we see associated with aerobic exercise versus resistance training are kind of different. So it'll be interesting to take a look at those as well. Okay, so we're going to start with acute aerobic exercise. Okay, so again, when we think about aerobic exercise, we're talking about moderate intensity, at least 3 minutes in duration. Okay, so what are some changes that we plan to see when I do one single run, for example, or one single exercise bout? Okay. So we're going to see changes in heart rate. Heart rate will increase linearly as it relates to the intensity of the exercise. Okay, so if I go out for a light, nice, easy jog or a walk, my heart rate will increase a little bit. If I go out and run as hard as I can, my heart rate will increase substantially. Okay, so again, heart rate will increase in a linear fashion as it relates to the intensity of the exercise bout. Stroke volume will also increase. Again, stroke volume is the amount of blood that I whoosh out in one single contraction of the heart. So I'm going to see an increase in stroke volume as I complete that one given exercise task. And again, that's a component that we talked about in the cardiovascular physiology section of this course. So that should be a review for you. Systolic blood pressure will increase as it relates to the increase in stroke volume. Okay, so as stroke volume increases, systolic blood pressure will also increase. And again, systolic blood pressure is the pressure exerted on the vessel walls as I am contracting the heart. Okay, diastolic blood pressure during aerobic exercise will not change. So diastolic pressure will remain the same during that given exercise bout because of a decrease in peripheral resistance. So I'm able to open up my vessels a little bit wider. So that helps me to maintain diastolic pressure, or the pressure that's exerted when the heart is in relaxation. Blood flow distribution, how will this be modified during one single exercise bout? Well, I'm able to send more blood to my skeletal muscle, for example, and less blood to places like my stomach, my intestines, the digestive system, those particular places, because I'm more concerned with delivery of oxygen and nutrients to the muscles that I might be utilizing. Okay, when we think about the respiratory system or the pulmonary system, what are some changes that we would see during one single exercise bout? We'll see an increase in tidal volume and respiratory rate. So again, tidal volume is the amount of air that I bring in one breath. Respiratory rate is the number of breaths that I'm taking per minute. Our bronchial tubes will experience some vasodilation. So again, they go from like this size to this size. Okay, so vasodilation, they got larger, and that's going to allow me to bring more air in. So that's good. Our oxyhemoglobin dissociation curve will shift to the right. And again, that's going to shift to the right as we see an increase in temperature, an increase in waste products, such as hydrogen, for example. And that's good because that's going to allow us to deliver more oxygen at the level of the tissue, at the level of the muscles. Okay. Respiratory exchange ratio, again, this tells us information about how much CO2 we are producing and how much oxygen how much oxygen we are utilizing versus how much CO2 we are producing, okay? It also gives us information about which fuel we're utilizing. Are we using carbs or are we using fats as our fuel source? And we'll see that with aerobic exercise, during that acute exercise bout, we'll see an increase in respiratory exchange ratio, which tells us that we're burning more carbohydrates than fats. We're utilizing, more oxygen potentially. Okay. All right, speaking of metabolic factors, that kind of leads us into our next slide when we think about acute aerobic exercise. At the onset of exercise, we're going to see an immediate increase in blood glucose levels. So that tells us that we're going to utilize sugars right away when we start the exercise bout. And in general, we think about caloric expenditure or metabolic rate. As exercise intensity increases, metabolic rate will also increase. Okay, so if I'm going to do a nice light jog or walk or something along those lines, maybe I'm burning 400 calories per hour. And when I increase that intensity and I'm running as hard as I can, maybe I'm burning more like 800 calories per hour. Okay, so the number of calories or my total metabolic rate will increase linearly as it relates to exercise intensity. Okay. We can also think about which fuel we are using in multiple scenarios as it relates to acute exercise. So if I'm doing something at a low intensity, I tend to prefer to use fats as a fuel source. Okay. During high intensity exercise, I prefer to use carbohydrates as my fuel source. And the reason for that is our bodies are more efficient at using the carbs. It's easier for us to use that as opposed to the fats. And then if I'm doing prolonged exercise, greater than 60 to 90 minutes, I'm going to rely heavily on fats as a fuel source. Okay, so low intensity is fats, high intensity carbs, and then prolonged exercise greater than 60 to 90 minutes will be fats as well. Okay. So when we think about what's happening within our communication systems, so again, the endocrine system and the nervous system, we will see changes in both. Again, when we think about exercise as a stressor against the body, remember that this stressor is going to affect like every single system of the body, which is pretty freaking cool that our body works together like a team in order to allow us to achieve, you know, whatever it is this task might be. So that's pretty freaking cool. So again, hormonal changes, we're going to see an increase in epinephrine, norepinephrine, ADH or antidiuretic hormone will increase, and cortisol will also increase. Okay, so let's take a look at what each of these does. So epinephrine and norepinephrine are also known as like adrenaline. So again, those are like feel-good hormones. So when I release those, like when I do the exercise, it makes me feel good, right? So again, maybe you have experienced before like, oh, I just don't really want to, I don't feel like doing anything. I don't feel like really exercising, like I'm just not in the mood for it. And then you go and do it, and then you're done. You're like, wow, that felt really good. Like, I'm really glad I did that, right? The reason that you feel that way is because you got this adrenaline release, okay? So epinephrine, norepinephrine make us feel good, okay? So those are good things. Again, that's, and we'll talk about this when we get to the chronic exercise section of this unit, but the release of those is really great because it's going to help us to potentially prevent depression in people. Okay, so again, one thing that we would want to prescribe to people that are, you know, suffering from depression is exercise. You do some exercise and you're going to feel good because we're releasing these particular hormones. Okay. Antidiuretic hormone, again, has to do with fluid retention. So antidiuretic hormone will increase, and that'll allow us to retain fluid so we're not peeing it out. And so that's good because then we can save that fluid so that we can sweat if thermoregulation becomes an issue for us. Okay. Cortisol, its job is to increase blood sugar and increase fat metabolism. So again, it gets those fuels out ready to go so that I can use those because of this increase in metabolic rate. So that's good news. Okay. We think about neural changes. Certainly we want to activate the sympathetic nervous system. Again, that's our fight or flight system. So again, the activation of that is super beneficial for us because it is all encompassing and it is going to stimulate many systems of the body. We'll also see the recruitment of appropriate motor units. So again, if I'm doing something like swimming, for example, okay, which muscles do I need to activate and which patterns do I need to activate will be recruited as it relates to those neural changes. Again, when I go through warm-ups, for example, In swimming, I might start with, you know, a couple minutes, maybe like 5 minutes of easy swimming. And then I'm going to go into like what's known as a drill set. And in the drill set, I'm kind of focusing on different portions of my technique so that I can kind of activate the appropriate motor plans. Okay. So motor plans are stored within the cerebellum, and these are kind of like your automatic plans associated with coordinated activities. Okay. So for someone who's a swimmer, I have a motor plan for when I do breaststroke, for when I do freestyle. Okay, so for each of the different types or each of the different strokes of swimming, I have a different motor plan for each of those. Okay, so I'm going to activate those once I start doing that activity, and then it becomes more automatic in nature again. Same thing, I'll use basketball as an example again. But same thing we would see in basketball. I have a specific motor plan for when I shoot free throws. Okay, so I get on the line and I probably do the same little routine every time, right? I do 2 bounces, rotate the ball and then sit down and shoot, right? So again, I'm activating that motor plan from the cerebellum every time I want to do that activity. It becomes automatic in nature. All right, so here you can see the hormonal changes associated with graded exercise. So graded exercise means incrementally increasing intensity. Okay, so at a low intensity, I have a small amount of change, but not a whole lot of change. Okay, and as intensity increases, you can see that the release of these hormones also increases. So epinephrine, norepinephrine, which are two that we talked about, meaning adrenaline, it's super beneficial for us to see these released. And the harder I work, the more of this sensation I'm going to get at the end of the day, right? Doing a light, easy walk isn't going to make me feel as good as if I do like a nice hard exercise bout of, something a little higher intensity. That's going to make me feel really good because I get more release of this. Okay. Insulin is the only hormone that we're going to see decrease when I do acute exercise. And the reason for that is insulin's job is to store fuel. It's going to help us to store sugars. Well, I don't want to be storing sugar while I'm exercising because I want to be able to use those sugars. So I'm going to shut off insulin and turn on glucagon, which is going to allow me to use those sugars. So again, that gives us a kind of a general gist of what's happening on acute side as it relates to aerobic exercise. Now we're going to flip over and take a look at what happens during acute resistance exercise. Okay. So resistance exercise, I'm doing something in the weight room, right? I'm lifting weights, I'm stressing my muscular system. I'm not necessarily looking to be out of breath, right? I'm looking to stress my muscles so that I can gain muscular strength, muscular size, etc. Okay. So again, when we see what happens within the cardiovascular system, we know that we'll see an increase in heart rate. Again, this is directly related to the intensity of the exercise bout and the amount of muscle mass that I'm activating. Okay, systolic blood pressure will increase substantially and diastolic blood pressure will increase substantially. Okay, so again, as I create this compression on the muscles via the contraction of certain muscle groups, that's going to create more tension for the vessels to overcome or compress those vessels, and therefore we'll see a substantial increase in diastolic and systolic pressure during acute resistance exercise. Okay. We're also going to see a modification in blood flow, and this is known as transient hypertrophy. Okay, so have you ever gone to the gym or done a lift or whatever, and you leave and you're like, wow, I already feel stronger, like I feel like my muscles are already bigger, right? Sometimes this is called the pump. Okay, so basically what happens when I'm doing this single individual exercise is I'm sending a bunch of blood to whatever muscles I'm activating. So let's say I did a bunch of push-ups, for example, okay? I'm gonna send a bunch of blood to my shoulders, to my chest, to my arms, whatever muscles are activated during that push-up, and that's gonna make those muscles temporarily look larger, which is really nice. Again, we see people, like people that do bodybuilding and things like that, we see them doing push-ups and things like that backstage before they come out on stage. Again, they're not just trying to get like a one last workout in, they're trying to maximize their pump, right? They're trying to get more blood flow to the muscles so that their muscles look larger. Okay, so that's what transient hypertrophy is. It's the change in distribution of blood to whatever muscles you activate. And again, how much transient hypertrophy I experience has to do with what muscles I'm activating and at what intensity am I activating them. Okay, so if I do 5 push-ups, well, no big deal, that's not that challenging. If I do 100 push-ups, right, well, maybe that is super challenging, and so I will see more transient hypertrophy in that particular scenario. Okay. Okay, so when we think about, sorry, I'm just confused on my notes here. Oh, 50, okay, sorry. Anyway, so again, when we think about acute resistance training, how does this affect the endocrine system? We'll have more of an endocrine response when we do resistance training as opposed to aerobic exercise, particularly when we think about these top 3 things. So cortisol, growth hormone, testosterone, those will all increase. Epinephrine, norepinephrine, those will also increase, but to a smaller extent than what we would see in comparison to aerobic exercise. However, you see more of a change with cortisol, growth hormone, testosterone, and those are going to help us to facilitate muscle recovery and muscle growth, which is what we're after if we're doing resistance training. We're not just doing it to like stay the same, like we want to get better, right? You want to get stronger or you want to get larger or whatever that particular goal is, right? So these hormones can assist in those processes. So increase on all fronts. Again, when we think about the chronic changes associated with regular resistance training, these top 3 are pretty darn important for us. Okay, what about the nervous system? How is the nervous system affected by acute resistance training? We're going to recruit type 2 muscle fibers or those fast twitch muscle fibers. Again, those will be activated and utilized when we're doing strength training. We're also going to activate the sympathetic nervous system. The extent to which we activate that certainly has to do with the intensity of the exercise bout that we are completing. Okay, when we think about metabolic factors, again, our overall metabolism or our overall caloric expenditure is again directly related to exercise intensity. Okay, so if I go into the weight room and I'm like, you know, just kind of doing some lightweight things and, you know, not really pushing myself too hard, maybe I'm burning 300 calories an hour or something like that. But maybe I go in there and I'm ready to freaking crush it. And I'm like, you know, hitting squats as hard as I can and, you know, activating a large amount of muscle mass. Sorry, I keep looking outside because my office window is open and there's a bird right out there. And one time, like a couple of weeks ago, that bird freaking flew into my office. So if you like hear me start screaming or something, it's because that bird is in my freaking office. But I'm keeping my eyes on him, so hopefully he doesn't make his approach into the office. So anyway, so increase in overall caloric expenditure with an increase in intensity, just like what we would see with aerobic exercise. One major difference that we see with resistance exercise is our fuel source is exclusively carbohydrates. Okay, we're absolutely relying on carbohydrates as our fuel source during acute resistance training because we're using kind of those top 2 energy systems that we've talked about in this class. So the ATP phosphocreatine system and also that anaerobic glycolytic system. So we're utilizing those particular systems, which means that we are exclusively relying on carbs. Okay, so again, that kind of gives us an introduction to what's happening as it relates to acute exercise. Notice that I didn't include a section on intermittent sport or intermittent exercise because intermittent exercise is really difficult for us to research, right? Again, let's think about football, for example, right? The demands of a wide receiver can be different every single game. It depends on your opponent. It depends on the weather. It depends on, you know, which plays we're going to run that particular day. Okay. So we got to think about that. Then also let's think about the diversity of players that are on a single football team, right? So my wide receiver versus my quarterback versus, you know, a lineman, they're demands are going to be substantially different from each other, but also different day to day, okay, depending on, you know, the scenario, depending on who you're going up against and that sort of thing. So it's very difficult for us to kind of nail down what's happening in that particular realm. So a lot of times with intermittent sports, such as like football, basketball, soccer, etc., we just use bits and pieces of resistance training information and bits and pieces of the aerobic piece as well. Okay. So let's take a look at chronic adaptations associated with aerobic exercise. And the first two that I want to take a look at are related to the heart. Okay, so aerobic exercise training. So again, regular exercise training consistently over time, over many weeks, over many months, etc., will cause an increase in the heart mass and heart volume. Okay, so the mass, like we're talking about, like the muscle mass associated with the heart will increase in like its thickness. And when we talk about volume, we mean the chamber volume. So the chambers will become enlarged and the walls of the heart will become thicker. Okay. Heart volume may increase 25% compared to sedentary individuals. Okay. So as an endurance athlete myself, like I take pride in knowing that I have a big heart, right? So again, this is pretty substantial when we think about this in comparison to sedentary individuals. And two different components that we're looking at here when we think about cardiac changes. We have eccentric hypertrophy and concentric hypertrophy. Okay. Eccentric hypertrophy is when we increase the size of the chamber. Okay, so instead of the chamber being able to hold 50 mils of water, I'm just making these variables up, it's able to hold 75 or whatever. Okay, so the cup or that chamber has gotten larger on the inside, so I'm able to hold more blood. Okay, concentric cardiac hypertrophy has to do with an increase in the thickness of the chamber walls. Okay, so the greatest adaptation that we want to make as aerobic athletes is this eccentric hypertrophy. We would prefer to increase the size of the chamber. Concentric hypertrophy will be a modest change in comparison to how much eccentric change we can experience. Okay. So what causes the increase in cardiac mass? Again, we're going to increase plasma volume. That's going to cause dilation or stretching of the left ventricle, similar to that of like filling a water balloon. Okay, so again, if I do that consistently, time after time, we'll see these modifications kind of stick around, which is good. Get myself a little more organized here. Okay. All right. So what about some of these other cardiovascular factors? And notice the complexity and the extent to which we're talking about cardiovascular factors as it relates to aerobic exercise. Again, you've probably heard aerobic exercise called cardio before, right? So it makes sense that we're seeing a lot of changes as it relates to aerobic exercise when we do this chronically. Okay, so I already alluded to this on the previous slide, but plasma volume, we're going to see a substantial increase in plasma volume, 12 to 20% after 3 to 6 aerobic exercise sessions. So like that's barely anything. Look how freaking cool our body is. We're able to see a huge modification. Like this is a substantial change just by getting out there and running for a couple times, right? 3 to 6 sessions. Well, I could do that in one single week. Okay. So again, substantial changes are being made very quickly as it relates to the cardiovascular system. Okay. So why is this happening? So we're going to see an intravascular volume expansion, and this is directly related to synthesis and retention of plasma albumin. And plasma albumin is like a protein. So we have like this protein kind of floating around in the blood. And as I do a few exercise bouts, I'm able to have more plasma albumin made. And so therefore it like pulls water with it basically. Okay, why is this good? A lot of reasons why this is good. So it's going to enhance our end diastolic volume, which is like the amount of blood that I can have in the left ventricle. That's going to allow us to increase stroke volume, or the amount of blood that's sent out in one single whoosh or one single contraction. Enhances oxygen transport, so I'm better able to carry oxygen in the blood. Increases VO2 max, or the maximal amount of oxygen that I can consume in any given minute, and also improves temperature regulation because I have more fluid. I have more fluid available then to assist with sweating and things like that, or manipulating where we want to send the heat. Okay. Also increase in hemoglobin, which means I can specifically carry more oxygen. Okay. So when we think about heart rate and how heart rate might change with chronic exercise at rest, I'll give you these details first and then I'll kind of explain why. At rest, my heart rate will decrease. During submaximal exercise, my heart rate will decrease. During maximal exercise, no change. Okay. So let's talk about why this is. So at rest, my heart rate will decrease because I have an increase in stroke volume. Okay, so I'm able to send out more blood in one single contraction. So instead of doing this, I'm able to do this. Okay, so again, I'm sending more blood out, but less times per minute. So at rest, heart rate decreases. Submaximal exercise, I want you to think of it this way. Okay, imagine that I am new to exercise. I haven't really done anything like that, and I decide I want to get into running. I know I keep using running as an example, but it's an easy one for us to kind of picture. Okay. So imagine I go out and I decide I'm gonna run 1 mile. Okay. So I go out to the track here at Loris and I run my 1 mile, and I can do it in 10 minutes. Okay. So I'm able to complete that mile in 10 minutes, and that's pretty challenging for me. Let's say my heart rate is, I don't know, 162. Okay, so that's a pretty tough intensity for me. Okay, so my heart rate was 162, and I was able to complete the mile in 10 minutes. Okay, so now I'm starting to train more, and after weeks and weeks of running regularly and that sort of thing, I decide to go back out to the track and run that mile again. Okay, so if I run that mile at the same pace as what I did before I started training, so I go out and I run that 1 mile in 10 minutes, my heart rate's going to be significantly lower. Okay, so it was like 162, I think is what we said the first time. Maybe now it's 145 or something like that. So the absolute intensity stayed the same. However, my heart rate decreased in order to do that same amount of work, if that makes sense. So submaximal exercise, we see a decrease in heart rate. Maximal exercise, again, no change in maximal heart rate. When we think about maximal exercise and how we can improve in this realm, heart rate's not one of the ways, right? Stroke volume is more important for us as it relates to maximal exercise. We have a greater potential to see change in stroke volume at that particular level. Okay. So speaking of stroke volume, at rest, submaximal, and maximal exercise, all three are going to increase. Okay, so stroke volume. Sorry, making sure I got everything in my notes. Yeah, stroke volume will increase in all three conditions. Again, the increase in stroke volume is a significant contributor to our ability to increase VO2 max with regular chronic training. Okay. Blood flow distribution, we'll see an increase in capillaries leading to the skeletal muscle. And the cool thing about this is increasing capillaries like in the skeletal muscle. This is very specific to the muscles that you train, okay? And the way in which you activate them. So for example, let's say I'm a cyclist, okay? And I'm biking regularly, like 3 times a week or 4 times a week or whatever, every week, every month, etc. Okay, I'm going to see an increase in capillary density in my legs, in the muscles that I'm using in my legs. But like when I bike, I don't really need my upper body like a whole lot, right? Like I'm not really doing anything with my upper body. It's mostly just my legs, right? So the capillaries in my arms might look the same as someone that's untrained. So it's cool that we can manipulate like specifically where we want to see these changes, which is cool. What about pulmonic factors? What can happen within the pulmonic system or the respiratory system with regular training? Ventilation can increase during maximal exercise slightly. This is due to an increase in tidal volume and breathing frequency. During some maximal exercise, we become a little bit more efficient at breathing. So we'll see reduced amount of fatigue in our ventilatory muscles, such as the intercostals, the diaphragm, pec minor, and sternocleidomastoid. Okay, neural factors, again, I'm going to become better at synchronizing our motor unit firing. So again, I'm better at being able to get everybody kind of like on the same wavelength for contraction of the muscles due to when we're stimulating the motor units or those the motor neurons. We're also better able to recruit the appropriate motor units as well. Okay, so we're able to activate the appropriate motor units that we need to. Your body can do that faster earlier on in your warm-up in that particular case. Okay, hormonal factors. This is unfortunate in my opinion. Chronic training actually increases the threshold for the release of those adrenaline related hormones. Okay, so we said epinephrine and norepinephrine are like these feel-good hormones, and when I do exercise, I get this release and it feels really good, and I finish my workout, I'm like, wow, I felt so glad I did that. That felt great. Okay, unfortunately, you get addicted to that as an athlete or as an avid exerciser. We get addicted to that feeling. But what happens is now it gets harder and harder for us to get that release again, right? So the threshold is increased. I have to do more and more in order to get that same release, to get that same feeling, which kind of sucks. Like I want to just go out for like a 30-minute run and be able to experience that feeling. But no, as you do 30-minute runs a lot, you got to do more and more and more in order to get that same release as what you might have as a beginner. How is our muscular system modified with chronic aerobic exercise? So we'll see something known as selective hypertrophy. So we'll see an increase in muscle size that's only specific to the slow twitch muscles. Okay, so like our endurance athletes will have really big muscle fibers or really big muscle cells that are slow twitch, and then like their fast twitch fibers will be smaller. Okay. We'll also see an increase in myoglobin in those slow twitch fibers, which allows us to carry oxygen from the edge of the cell into the mitochondria so that it can be used. Okay, so when we think about some of those metabolic factors, again, we're kind of zooming in on what's happening within that individual cell. Okay, so we'll see an increase in metabolic machinery, which means that we have more mitochondria. We have higher enzymatic concentration. So again, we think about like if I'm an ultra endurance athlete and I'm doing a lot of like long duration types of things, so like really long, 2-hour run, 3-hour bike ride, something along those lines, I'm going to see higher enzymes related to like fat breakdown, because fats would be my major fuel source there. I'll also see an increase in fat metabolism or an improvement of efficiency as it relates to fat metabolism. We become better fat burners. Okay. Increased lactate tolerance during maximal exercise. So again, our maximal capacity to complete exercise at super high intensities will increase, because your body's like, oh yeah, you like to like do things that like are painful, and your body becomes more used to that. And so it's more comfortable being at those like painfully high stimulus types of scenarios. We'll also see an increased or an enhanced capacity to oxidize carbohydrates during maximal exercise. So again, our metabolism will improve at that particular level as well. Okay. I would be a bad kinesiologist if I didn't talk about some of the health-related benefits of doing chronic aerobic exercise. So again, I'm super interested and super passionate about sports performance. Like that's everything as it relates to my research and that sort of thing. But like also like most people don't care about that. Like we think about the average person in our country, or the average person that you'll be working with. A lot of you desire to be physical therapists, for example, or someone else in the healthcare field. You're not working with athletes, you're working with the average person, right? So there's many health related benefits associated with completing aerobic exercise as well. Okay, so we're going to see a reduced risk of cardiovascular disease, hypertension, high cholesterol, type 2 diabetes, cancer, osteoporosis, depression, and all-cause mortality if I do 30 minutes of moderate exercise 5 days a week. Okay, so again, yes, I'm trying to sell you on doing aerobic exercise or doing exercise in general, but man, we see the top causes of death right here at the top of the list, for us being able to reduce those risks, right? So if I do exercise, I can reduce my risk of dying. Like, wow, that sounds pretty nice. Okay. So again, a lot of great benefits associated with doing just moderate, it can even be low intensity aerobic exercise. So many health related benefits as well. Okay, so next we'll look at some of these chronic changes associated with regular resistance training. Okay, so when we look at resistance training, again, within 3 to 6 months, we can see significant improvements in muscular strength, 25 to 100% increase in muscular strength. Again, for beginners, the learning effect accounts for about 50% of this change. And this learning effect is generally going to be related to neural adaptations, or our ability to improve the coordination of stimulation of the appropriate neural pathways. Okay. But again, this all depends on like what our initial fitness was. Okay. So if I'm already kind of fit to start with, then maybe I'll gain 25%. If I've like never done anything ever in my life, then maybe I'm going to see more like a 100% increase. Okay, so again, when we look at the neural modifications with chronic resistance training, again, I'll see an increase in frequency and motor neuron stimulation. Additionally, I'm able to have better synchronization of the motor units, so I'm able to stimulate them in a more coordinated fashion, which would allow me to increase my force production. I'm also going to see a decrease in autogenic inhibition from Golgi tendon organ. So basically what that means is it's more difficult for us to activate the Golgi tendon organ, which is good because then I can produce more force before the muscle like gives out. So that's good news. Okay. Other modifications that we see, I'm going to see selective hypertrophy of those fast twitch muscle fibers. So again, people that do regular resistance training will see an increase in size of the fast twitch fibers that they have, while their slow twitch fibers will remain the same. Okay. We'll see an increase in myosin and actin filaments within each individual muscle fiber, which means that I'm able to increase force production within each individual cell. Hyperplasia means increase in the number of muscle cells that we have. We don't think that this can happen. We think that you have a certain number of muscle cells and you can increase the size of those through this hypertrophy mechanism. But we don't think that we can produce more cells themselves. Okay, so we don't believe that hyperplasia is going to occur. We're also going to see an improvement in bone strength and bone metabolism. And the reason for that is the muscles are attached to the bones, as you know. And as I stimulate those muscles, they're going to pull against the bone. And the pulling of the muscles against the bone is going to improve the muscle metabolism, which in turn will also help us to maintain or improve bone strength. Okay, when we think about hormonal changes, I see a decrease in fat mass. Okay, so as I become more fit as a resistance training person, I see decreases in the amount of fat that I have stored. And so I'm also going to see a decrease in leptin. Okay, leptin is a hormone that enhances our feelings of fullness. So a decrease in this will cause us to have a larger appetite. Okay, so again, in theory, if I have a low amount of fat tissue, I have a low amount of leptin, which means that I have to eat more in order to feel full, which is I like that. That's a good thing. I want to be able to eat a lot. I love food. And then an increase in testosterone levels is debatable. Some researchers have found that we will increase testosterone levels as a result of regular regular resistance training. Others haven't seen this to be a huge important component for us. Okay. When we think about what happens within the cardiovascular system, not a whole lot of change going on. Again, our goal with resistance training is to really focus on the neuromuscular pathways. And so cardiovascular system isn't having a huge change, but we will see concentric hypertrophy of the heart walls. So there will be some thickening of the heart walls, and this will be due to the increase in heart rate and blood pressure that we see during each of those individual exercise sessions. Again, kind of already alluded to when we talked about the hormone leptin, but we will see improvements in body composition related to either type of exercise, but maybe more so with regular resistance training. So we'll see an increase in muscle mass, a decrease in body fat percentage, and the combination of those two factors will allow us to increase or improve our resting metabolism. So again, I'm burning more calories while I'm at rest, okay? And again, that's probably directly related to the increase in muscle mass. So the more muscle mass I have, the more calories I need to maintain that particular muscle mass. And like I said, we'll also see this decrease in body fat percentage. Again, other metabolic factors to think about. So we're going to have an increase in levels of anaerobic substrate. So these are like the fuels that I need in order to do anaerobic exercise or in order to do resistance training. So I'm going to see increases in ATP, phosphocreatine, and glycogen as well. So again, that'll allow me to utilize like the ATP phosphocreatine system and also the anaerobic glycolytic system. So we're able to like improve those particular systems with regular resistance training. Increased quantity and activity of rate limiting enzymes. So again, if you remember back to our unit on metabolism, we talked about the rate limiting enzyme being the slowest portion of an overall reaction. So for example, within glycolysis, there's 10 or 12 different reactions that occur. And so whoever is the slowest reaction within that series determines the overall speed of the process, okay? So with which energy systems are we concerned with? Again, with anaerobic glycolysis, PFK was our rate limiting enzyme. So if I wanted to improve my ability to utilize that system, I would have more of PFK available. Okay. So that's the enzyme that we're talking about here. We'll also have an increased capacity to generate high levels of blood lactate during all-out exercise. Again, we saw that with aerobic exercise in the chronic sense as well. Again, I would be a bad kinesiologist or exercise physiologist if I didn't tell you about some of the health-related benefits associated with regular resistance training. It's recommended that the average person, again, we're not looking at sports performance or anything else like that, just the average person, if they want to gain health-related benefits from resistance training, they should complete 2 to 3 resistance training bouts per week. You can do 8 to 12 exercises per session. 20 to 30 minutes per session seems to be enough time to be able to get this done. And we're going to see an improvement in self-confidence, an improvement in body composition, a decreased risk for depression as well. Okay. So that is all for today. Again, please reach out to me if you do have any questions on exercise phys.